Well, Mike Poland is a geophysicist from the U.S. Geological Survey with us now, and to talk more about the eruption's impact and what dangers could lie ahead. Mike, you actually specialize in what drives volcanic activity like this, and using satellite data, which we saw some of the pictures there, they're incredible, to forecast future eruptions. Talk to us about the data that you are looking at right now, and what have you actually learned about this eruption, Mike, and how much did we actually know about this volcano before the eruption?
Well, we knew a fair amount about the eruption because geologists had been to the island to examine it. They knew that there were some potential for large eruptions based on the ash deposits they'd seen there and on neighboring islands. But the historic activity had been relatively minor. So this was certainly the biggest eruption that we'd seen from this volcano historically. In terms of the data we're looking at, it's mostly coming from satellites. A lot of the ash fell into the ocean. So in terms of trying to understand this eruption, it's really about the satellite data at this point, and it's really a bit contradictory in some ways. The ash plume, as you can see there, was absolutely humongous. And the amount of gas and ash that came out seems to not be commensurate. It doesn't quite add up to a plume that big. So there's something maybe about the interaction between magma and water that we don't quite understand that must have helped to drive this eruption.
So what's the biggest danger in an eruption like this, and how much warning did Tonga even have?
Well, the volcano had been erupting for a couple of weeks prior to this, with some intermittent small explosions, obviously nothing near this big. But undersea volcanoes are a tremendous challenge to monitor. It's incredibly expensive to get instrumentation down there, and then actually monitoring that activity in real time. You'd have to have a cable or something like that to get the data back to the surface. So there was some indication that there was activity at the volcano. It had been sort of erupting off and on for a couple of weeks. It would have been difficult to forecast this kind of event just because we don't have the data we need. On land volcanoes, we can have seismometers, GPS stations, instrumentation that helps us see magma accumulating, but that's really hard to do on an undersea volcano.
Well, what needs to be done, or can anything be done, to get warnings out faster?
Well, there's clearly needs to be more of an emphasis on submarine volcanoes and the hazards that they pose. It's not something that we understand that well, and there aren't that many volcanoes, perhaps a few dozen that are in that sort of special spot right near the surface of the sea, right at that ocean air interface. That's where the real explosive activity can happen on undersea volcanoes. But I think this demonstrates we got to spend more time and effort understanding these submarine hazards, and that may include monitoring. Putting more stations on islands to see those undersea volcanoes that are nearby, and perhaps having some cabled observatories, underwater observatories that can help us see this kind of activity before it really gets big like this. We're never going to stop volcanoes from erupting, but if we can get people out of the way and warn them to hunker down and eruptions on the way, that's our best defense.
Mike, we just not long ago did a massive project on climate change here on ABC News Live. So kind of bringing it together to what we're seeing here in Tonga. How could a massive eruption like this affect the climate? And is it a sign of the climate and how it's shifting?
Well, for this particular eruption, it doesn't look like it'll have that much of a climate impact, fortunately. When we think of big climate impacts, we think of eruptions like Pinatubo in 1991 in the Philippines. That was a really massive eruption, and it pumped a tremendous amount of ash and sulfur dioxide gas into the atmosphere. And that creates an aerosol that reflects sunlight back, and the sunlight doesn't get back to the surface of the Earth to warm the planet. So that reflected sunlight means we had lower temperatures, slightly lower temperatures for a year or two after Pinatubo erupted. This eruption looks like it pumped about 50 times less of that sulfur dioxide gas into the atmosphere, at least preliminarily. So that's really not enough to cause climate impacts. And these sorts of eruptions don't seem to be influenced themselves by climate. There are some places where things like melting ice sheets might remove some of the pressure that keeps a volcano sort of from erupting. So there are places like Iceland where we may see some increased volcanic activity as ice sheets go away. But climate change in general, it's difficult to see how it would cause an eruption like this one. This is just a case where magma accumulation kind of hit the right spot, and there was some activity to trigger this sort of event.
Yeah, it was pretty massive. Mike Poland from the USGS. Always appreciate the conversation. Thank you so much.
Thanks very much.